At last, we have reached the end of Chapter 3. Exponentials and logarithms will come to a close today. We finish up talking about everybody's favorite concept, money. At least it's my favorite concept. Simple interest and interest that is compounded annually. Let's go interest. Let me explain the difference between simple interest and interest that compounds annually. Conceptually, what's the difference? Well, when you say that something compounds annually, that means that every single year the lockdown drill. Completely forgot about this. Ah, crap. Okay, we've all survived the catastrophic lockdown drill. Anyway, before we had to pause the video, I was talking about the difference between simple interest and interest that compounds yearly. So here's how interest that compounds yearly works. Let's assume you have money in the bank account. Okay, so let's say at the end of the year, one time, you're going to get some interest. Boom, 5% interest. And let's say you never touch that money again. That means you now have more money in the bank. You have 5% more than you used to have. And if you don't touch it again at the end of the next year, you get another 5% bump. But that's 5% of the original money plus 5% of the 5% you earned last year. So basically what happens when you compound annually is your interest gathers interest over time, kind of like a snowball rolling downhill. It's going to gather some snow. So what is simple interest? Well, simple interest is something that unfortunately no banks use. I wish they did, but they don't.
Excuse me, Mr. McCutcheon, you're not
I'm not sharing the video, of course not, because I don't know how to do my job. Hold on. Well, let's see, share the video, because this is just like, this is how you make quality YouTube content. There you go. So anyway, like I was saying, simple interest is something that no banks use, but I wish they did. Simple interest doesn't compound on itself. Instead, it just goes, well, let's just say you have a loan. You owe this bank some money. At the end of the year, they charge you 5% interest. Okay, let's just say you never make a payment on it. The next year, they're going to charge you another 5%, but it is not going to be 5% of the 5%. It'll only be 5% of the original that's added. Easy math. Let's say you borrow $100. And the bank says we're going to charge you 5% simple interest per year. What that means is every year you're just going to owe them another $5. Instead of saying 5% and then 5% of the 5% and then 5% of the 5% of the 5%, so on and so forth. In fact, it's so rare that we're not even going to do any problems with it because nobody ever uses it, unfortunately. But we will use this one. Whee! That one right there. That one is exponential growth. It's just the exponential growth formula. Suppose Quan, and I didn't make that name up, it's in the textbook. Suppose Quan invests $5,000. Ooh, Quan is a baller. At 5% annual compound interest, how much money will he have after 10 years? What we have is our principal amount being 5,000. We have our rate. Remember, please, you cannot use the percentages as your rates. You must turn it back to a decimal, so this would be 0.05. And we have a time. Does the formula have a T in it or an N? Whatever. It's got an N instead of a T for number of times it compounds. 10 times because we're talking 10 years. So we want to know how much money we would have. Well, the formula just works like this. The amount of money we would have is 5,000 times 1 plus 0.05 raised to the 10. This is legitimately just a calculator question. 5,000 times 1.05 raised to the 10. Of course, you need to follow the order of operations. You would have to do 1.05 to the 10th, and then times 5,000. And let's see how much money we would have. 8,144.47. Ta-da! That's a lot of money, isn't it? That's not bad. It's too bad it's unreasonable. Banks don't offer 5% interest. I think the average interest rate right now is around 0.25%, 1/20th of this. So, oh well. We could all dream, right? We could all dream. So you need to have the exponential growth and decay formulas memorized, but you also need to have this formula memorized. This is compounding interest. This is if your interest compounds more than once per year. We have an extra variable, K. K represents the number of times per year your interest compounds. So if I say your interest compounds weekly, K is 56. If I say it compounds monthly, it's 12. If it compounds biannually, it's 12. Quarterly, 4. So on and so forth. And yes, I need you to memorize this formula. It looks kind of scary, but it's really not, because realize if I said it compounds annually, what does K equal? It equals 1, right? So if you replaced a 1 here and here, you would get back the exponential growth equation. So it is a version of the exponential growth equation. It's just what happens when there's multiple compounds per year. That's all it is. So let's scoot on down and talk about Roberto. Roberto invests $500. He's not as baller as Quan. $500 at 9% annual interest. 9% interest, good joke. Compounded monthly, okay, that's 12 times per year. We want to know how much money Roberto has after 5 years. So how much money Roberto has? Let's see, our initial investment, 1 plus our rate, remember, not 9%, 0.09. Dead giveaway that you forgot to move your decimal. Your answer will be in the millions or billions within 5 years. Money doesn't work that way. Divided by the number of compounds per year. And then we have it raised to the number of compounding times per year times 5. So that's a 60. The good news about 0.09 divided by 12 is it's a terminating decimal. It doesn't go forever. So we can actually type it pretty easily. 500, I think it's 1.0075. No, I don't remember. No, yeah, it's 0075. Raised to the 60. So you just grab a calculator, type it up, and we see that Roberto has about $782.84. Since you're talking money, you should always round to 2 decimals. And if you ain't talking money, I ain't trying to hear it. Nothing. Man, I swear. It's pretty easy, right? Knowing the formula is the hardest part. And it is just exponential growth that has the K not equal to 1. That's all it is. We ready to flip it over? See what's on the back? All right. Fine. Now, Judy and Roberto, I think they went to the bank together because Judy also has $500 and she's going to also invest at this bank, this magic bank that is offering 9% annual interest that's compounding monthly. But what Judy wants to know is how long until she has $3,000? Because, you know, Roberto had less than $800 after 5 years, and Judy's clearly she's got higher goals, right? She's trying to get to $3,000. So what we do is we just fill out the compound interest formula again, but this time I don't know T. That's the only thing I don't know. 3,000 equals 500. 1 plus 0.09 over 12. Man, I need an account at this bank. Raised to the 12t. You're trying to solve for t, so what would be the very first thing you did? Yeah, you divide by 500 on both sides. Well, that always would have been the first step. 3,000 divided by 500 gives me 6. The thing inside the parentheses is 1.0075 raised to the 12t. Before I finish this question, we're going to have an aside over there. And I want you to realize, I never had to tell you how much money Judy started with. I could have said something as simple as, how long until Judy's money is multiplied by 6? Or how long until Judy's money is tripled? Or something like that. I never have to give you the actual amount as long as I tell you what the multiplier was. For example, let's say Judy started with some principal amount. And there's some junk going on, right? And I say, how long until Judy's money triples? If she started with P, what would she end with? 3P. Now her money has tripled. The very first thing you would have done was divide both sides by whatever P was, right? And look what happens. You're left with 3 equals, and this stuff. My point is, it doesn't matter how much money you start with. Time that it takes to double, triple, quadruple, so on and so forth is the same, regardless of how much money you started with, because that's how exponential growth works. Just in case you ever see one of those questions, wink, wink, nudge, nudge, it's like, how long until it doubles, or something like that, okay? Okay, that was just a little side thought. We'll just separate that bad boy from the rest of the question, okay? A little side thought there. Cool. All right, Judy's chomping at the bit here. We need to know. We have, yes? What log base 1.0075 on both sides would work perfectly. But I don't want to do that. There's nothing wrong with it, but I don't really want to. But here's why. My exponent has more than one thing in it. And when the exponent has more than one thing in it, I feel that it is easier just to use the common log. It would work, and we would get the exact same answer. But if you use log base 1.0075 on both sides, you are going to have to remember how to do change of base. But if you just use the common log of both sides, it gives us the opportunity to review the concept that when your, that's supposed to be green, when your argument, okay, go home, computer, you're drunk. It gives me the opportunity to review with you the idea that when your argument has an exponent, you can move it to the front of the logarithm. I'm going to switch the equation around too. 12t log of 1.0075 equals log 6. Those are multiplications. You can isolate t in one step. Yep. Divide both sides by 12 log of 1.0075. No, Natalie, you suggested using log base 1.0075 of both sides. And that would work just fine. But at the end, when you go to evaluate it, you would have had to have changed your log base 1.0075 of 6 to log of 6 divided by log of 1.0075, which is change of base. So doing it this way just kind of gets around the idea of change of base. But yes, it would have worked just fine. All right, I'm just going to go ahead and tell you the answer, and then I'm going to teach you a neat trick on your calculators. This is about 19.98 years. Quite the long time. Now, my people that have the TI-30X2S, the nice solar-powered scientific calculator, this isn't that bad to do. You just have to make sure that you wrap your entire denominator, 12 log, yada, 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 in parentheses. However, the people that are using the TI-30XA, or the people that plan on borrowing a calculator from me on test day, because this is what you'll be using, this is not the easiest thing in the world to type in. Why? Because there's two things in the denominator. Kind of makes life a pain in the butt, doesn't it? I mean, you could just do log 6 divided by 12, divide by log of 1.0075. As long as you're comfortable dividing more than once, sure, go for it. But I figure I might as well teach you how to use a command on this calculator that you might not have known what it did. So anybody in the room have one of these that wants to hear? Lauren, you could use this one. Okay, Lauren, you ready? So that calculator sucks. So you're going to have to type things in backwards. Trust me on this. Let's go with the denominator first. 1.0075. Then hit log. Oh, you got to turn it on first. Okay. So 1.0075, then hit log. Now do times 12. Now do divide by 6 log equals. It's ugly, isn't it? Yeah. Now, one of the gray buttons has a 1 over x on it. Hit that button for me. Oh, it's that. Yeah. So what does the 1 over x button do? It flips your fraction over. So you can type it upside down if that makes your life easier. And then just tell the calculator, flip my answer over. Neat, right? Okay, so now you know how to use one more command on that calculator. And we keep on scrolling, finding an interest rate. Okay, Steven. Okay, Steven, you must be buddies with Quan and, or not Quan, Quan's a baller. Who is it? Roberto and Judy, because he also has $500. So Steven's got $500 to invest, but he's curious what annual interest rate, compounded quarterly, which is 4 times per year, is required in order to double his money in 10 years. Did I have to tell you how much money he started with? No. Just for funsies, let's pretend we didn't know. And we want his money to double. Anyway, compounding interest. 1 plus, shucks, we don't know R, but we do know that it's going to compound 4 times per year. And we have those 4 times per year times the 10 years. Since we're trying to solve for R, just like a moment ago when we were working with Judy's question, your very first step would have been to divide by 500. So you would have had 1,000 equals 500, blah, 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 and you would have divided both sides by 500, and you would have ended up with a 2 here. So it actually didn't matter how much you started with. The result was still going to be the same. 2 equals 1 plus r over n, r over 4, excuse me, raised to the 40. We're trying to find an unknown rate. How? How am I going to dig that r out of those parentheses? There's an easy way and there's a hard way. The 40th root is the easy way. Using logarithms is the hard way. Can it be done with logarithms using the common log and bring the exponent down to the front like I did just a minute ago? Yes, it can. But your answer is some kind of ugly 10 raised to the power of yuck, yuck, yuck. It's actually much easier to just take the 40th root of both sides. Like so. 1 plus r over n. Gosh, why do I keep doing that? R over 4 equals the 40th root of 2. I'm not going to bother trying to figure out what that is right now. Instead, I'm just going to get r by itself. Subtract 1. So r over 4. Okay, I'm like having a hard time today with this 4. R over 4 equals the 40th root of 2. And you get, okay, 2. Then you're going to subtract 1. And then, of course, you would just multiply both sides by 4. And there it is. And it's about 0.0699. Or 6.99%. So how would you type that on a scientific calculator? Well, on the TI-30X2S, the solar-powered calculator, yes, it does have the ability to do 40th root. what you would want to do is, and if it was me, because I think it would be easier, is I would evaluate the 40th root of 2 first on the calculator. The 30x2s has a what we call a caret button for exponents, but if you hit second caret, it brings up the x roots. What you need to do is you type 40 second caret 2 equals, then times 4, then minus 4. The 30xa can also do the x root. But you have to do it backwards. So you have to do 40, and then second, then the y to the x button, 2, enter, times 4, enter, minus 4. Did it work? Nah, something went wrong. I think you did. I think you missed the second button. Here, toss it. I'll catch it. I promise. All right, let's try. Oh, I had you type the radical in backwards. My apologies. So it would have been, yeah, so you do 2, second, y to the x, 40, enter, times 4, enter, minus 4, enter. Yeah, I'm sorry. You do argument first. That's right. This calculator does everything backwards. Argument first. I forgot. And lastly, something that never, ever, ever happens in the real world, continuously compounding interest. You know why it never happens? Because it's the fastest rate of interest there is. Therefore, no bank is going to offer it because they're not trying to give away money. But it does make for really good math problems, and it is useful for radioactive decay and growth rates of crystals and all kinds of things like that. So suppose a principal investment, P, is invested at an annual interest rate of R. The value of the investment, that is compounding continuously. You see continuously? You use PERT. PE to the RT. PERT. PERT, yes. So we need to know exponential growth and decay, we need to know PERT, and we need to know compounding interest. Suppose Tasha invests $100 at 8% annual interest, compounded continuously. 8% interest, wow. Find the value of her investment after 7 years. So Tasha says, all right, I got $100, and then E. Please remember, you cannot use the percent rate. You have to change it to a decimal. So it's not 8, it's 0.08. And how many years? 7 years. Legitimately, you pick up a calculator and you just ask the calculator how much money that is. 175.07. Now, could I ask you questions where I didn't tell you the rate or I didn't tell you the time, meaning you don't know part of the exponent? Absolutely. Then you would use ln's to cancel the e's after you've isolated the e and work your way from there. So yeah, even though it didn't come up in the notes, you do know how to do it and you are expected to do it. But that is it. Easy peasy, right? Told you.